You have to unmute
Hello?
yourself. Yeah, hello.
Hello. Okay, thank you for the introduction and sorry for the delay. The topic of this presentation is the development of 2050 national long-term energy plans for carbon neutrality targets. The idea is to use our model, the DESSTINEE model, to be able to predict national granularity.
Can you use the whole screen, full view?
Yes. To use national, the idea is to use our model to predict national granular energy demand, which are compatible with these emission reduction targets. So, as a bit of background, around 76% of greenhouse gas emissions within the European Union and the UK are associated with energy demand and energy supply, particularly regarding direct emission from demand. I mean, combustion in the residential sector, in industries, in transport. 52% of current greenhouse gas emissions come from there. As well, despite that quite a significant decrease in the fossil intensity of the economic matrix has taken place in the last years, still we have that fossil fuels contribute to 60% of our final energy demand, particularly in transport, in heating for buildings, and in industry. So what does carbon neutrality mean for energy demand? If we take a look at the impact assessment models that were conducted by the European Commission for the new targets, there are some indications about what reductions are expected for key sectors for energy demand. Particularly when we consider the 2030 targets, they announced in November, December last year, we need to achieve 55% of greenhouse gas emission reductions as a whole. On the whole EU should do that. That means that how that can be translated in terms of energy demand. Well, their studies suggest that in terms of fossil CO2 emissions, we expect certain caps in the residential, in the road transport, and in industry. The same in terms of the 2050 targets. So this is important for us because we have calibrated our model, or we have conducted our runs so that we meet these specific targets for these final energy uses. So when we talk about the climate change mitigation targets, we see that there have been several changes along the last decades about where the EU wanted to arrive in terms of its commitment to reduce greenhouse gas emissions. We have the first generation of targets in alignment with the first implementation phase of the Kyoto Protocol. Then we have from 2014 to 2018 targets associated with reduction by 2030, and by 2050 that were more compatible with the 2-degree, well below 2-degree target, and particularly the 2018 long-term strategy compatible with the goals of the Paris Agreement. However, in the last 2 years, we have decided to go even further and reach climate neutrality by 2050 with the purpose of reaching 1.5 degrees. So this is one of the objectives of the European Green Deal, approved in 2019, and in 2020 we have seen the approval of cut of 55% of emissions by 2030, and in the case of the UK, 68% by 2035. These targets are still not modeled at national granularity for the EU 27 countries, and research is ongoing to do that. So this is our contribution, or what we are trying to do. So the DESSTINEE model is an open access scenario generator, is written in Visual Basic, is quite user-friendly, it's open, it's free, you can download on internet. Since Excel is an interface, it's easy to see what are the input, what are the variables that can be modified, or our defaults. It reports result for 11 energy vectors, associated CO2 emissions for key and the final energy consumption, associated CO2 emission for key sectors in 40 countries. There are 3 modules. One predicts yearly figures, which is the one that we are going to, that we have used to conduct this study, but we also have other 2 modules that enable the prediction of hourly power demand, and also the design of the supply system in module 3, where we take assumptions about renewable penetration, and in renewable penetration and availability, and we estimate the different the different basket for the supply system. In this work, we have particularly focused on the module 1, which is the demand side, and how to translate these very high politically targets, very high level politically targets in terms of emissions into concrete actions for the demand sector. The final energy uses we have considered are heating in buildings, space heating, water heating, cooling, appliances. In terms of transport, we are analyzing what happens for cars, light duties, heavy duties, and buses, but also rail, navigation, and aviation. In terms of industry and agriculture, we are considering what we call light industries, which would be those manufacturing industry with low or intermediate thermal duty, agriculture, combustion in agriculture. And in heavy industries, we are accounting for steel and metals, chemical, and cement and minerals, which are industries that have a very high energy consumption in addition to specific process emissions. So in terms of methodology, what we have tried to is try to meet the reduction target in terms of emissions that have been proposed by the Commission for 2030 and 2050. One important thing is that we are assuming that the UK is behaving as if it were still a member of the European Union. We are in the process of including the new target for the UK, which are a bit more ambitious. But in this presentation, the UK would have followed the pathway that it would have had if it still were one of the 28 members. These targets have been, these targets were proposed with some impact assessment model which present continentally wide scenarios that we are trying, which inputs we are trying to somehow translate into national reality. However, we are doing this respecting the current distribution among for technologies and fuels among countries, as well as the relationship that could exist between certain technology deployment and income indicators. In terms of efficiency improvements, we are considering the efficiency improvement in these scenarios, but we are critically analyzing them, looking for independent studies as well. And it's important to say that in these studies, the countries' decarbonization efforts are together compatible with the EU-wide targets. We meet the EU-wide targets, but each country may have different reductions or different ways to achieve this reduction. It's worth mentioning, though, that we are not considering effort sharing or fair burden. We are not applying the national cap defined in the effort sharing directive, because again, the effort sharing directive is a directive that was approved in 2018, and that is also subject of modification considering the new target for 2032. As well, this is something that was politically defined, and this is a more scientific related exercise. So we may have a bit of difference in the caps when after running our model in the emission reduction and the caps, if you see the result from the effort sharing directive. However, this is, I would say, a more conservative approach, especially in terms of the reduction for the Eastern European countries or the countries with lower income. In terms of final energy and electricity demand, what we can see is that at the continental level, we expect significant, what we forecast, significant reductions for heating and road transport, which are mostly associated with efficiency improvement, for example, improvements in the building envelope efficiency, but also related to the changes in the fuel basket. The fact that we are introducing heat pumps or that we are introducing EVs with enable a higher service delivery, but with a lower fuel consumptions, enable the energy reduction, the final energy reduction, the reduction in final energy consumption, sorry. In terms of electricity demand, what we see is that electricity demand is significantly going to increase, consequence of the incorporation in these two sectors, and also as the wide spread of electricity in certain industrial processes, like we could consider steel manufacture. When we go at national granularity, we see different reduction levels that are aligned with the current distribution of fuels and technologies in a country, with the socio-economic trends that we will observe. There will be countries that will grow more, other ones will grow less, and that of course will translate in different trends for their service demand. And also we can see more availability of certain technologies within certain countries. As well, the traditional energy consumption pattern for the different nations. For example, we can see that the impact of heating is more noticeable in Northern European countries, here named as other northern. Meanwhile, in countries like Spain, we see that the reduction is mostly driven by the road transport because heating does not contribute as much. Then we see some countries where have more heavy industries development, where that sector will have a more significant contribution than other ones. In terms of the energy intensity of the economy, what we see is that what we see is a significant decrease between nowadays and 2030, but also, of course, with 2050. And in general, what we start to see is that by 2050, we reach a kind of that the numbers become more uniform independently of the country we are dealing with. In terms of energy per capita or final energy consumption per capita, we can observe that large Western energy using countries will experience a reduction in final energy per capita, which is quite drastic, whilst countries that are more in the Eastern Bloc will go in a slower growth or plateau. In terms of heating, as we were discussing before, there are two main drivers for the reductions in final energy consumption. One is the efficiency increase in terms of building envelope efficiency increase, that the buildings dissipate less heat. And another one is the modification of the fuel basket. And this is what we want to observe here. On the left plot, we see the final energy consumption, which decrease. And on the right, we see the service delivery, the amount of heat that we really need to generate. Both numbers decrease. However, what we observe is that we can differentiate or appreciate why the total final energy consumption for heating decrease, because we have a reduction of the amount of heat that needs to be delivered because the building becomes efficiency. And then we can observe the fact that we are delivering more heat but using less fuel due to the incorporation of heat pumps. This is mostly noticeable from the periods going from 2030 to 2050. Meanwhile, the impact of building envelope efficiency is more noticeable between nowadays and 2030. In terms of road transport, we have tried to do a similar analysis, considering the final energy consumption in the different countries.
You have 2 minutes. Okay.
And the amount of kilometers traveled. And what we see is that we have an increase of travel demand, But this travel demand is now satisfied using EVs, which are more efficient, and consequently our fuel consumption will be lower. And particularly by 2050, we have a carbon neutral fleet. This is translated into fossil CO2 emissions, as you can see here, where the largest reductions are observed, the cumulative observed for transport and heating. And finally, in terms of conclusion, what we see is that we require a significant transformation for reaching the 2030 and the 2050 targets. This transformation will not be uniform in the different countries, as we were discussing, associated with socioeconomic trends, but with technology, the deployment patterns. We are going to experience, or we're going to observe, a huge increase of power demand if we want to reach this target by 32% at the wide European level and 64% by 2050. This is not uniform, so they will have countries that will have to duplicate their power consumption to reach this target. And finally, we have tried with our model and runs that very strong efficiency improvements are needed to meet these targets. Some of them can be reached thanks to electrification, but even in that situation, we see that building efficiency increases, or even the increase of fuel economy for fossil fuel units need to be very high and sometimes very optimistic if we want to reach the emission reduction targets compatible with the climate change mitigation objectives. So I thank you very much for your attention. Hopefully I didn't go so fast, so you could get a message from here.
Yes, thank you very much. Absolutely. And people are very welcome to ask you questions or send messages in the chat. And thank you also for providing the address for downloading the model. Thank you.